Anita D'Amico. I'm from Code DX, and I'm here with Kevin Green and Josh Corman. Kevin from DHS and Josh from I Am the Cavalry. They'll introduce themselves and tell you a little bit about why we're all up here. But let me start by saying that we put this panel together because we have been watching for a while the Cyber Underwriters Laboratory being talked about and formed. In February of 2016, there was a presidential directive that said that this should be set up, and there's been some activity since then. But a lot of people are unaware of what the Cyber Underwriters Laboratory is about, and there are people who really question whether or not it's a good idea. Is it the best way of securing the Internet of Things types of devices? And so we're here today to discuss those, the pros and cons of the Cyber Underwriters UL to
the Cybersecurity Assurance Program.
The Cybersecurity Assurance Program. That's Joe Jarzenbeck from Synopsys, and Joe is an expert on the CAP, the Cyber Assurance Program, and the Cyber UL. And there are a lot of other people here who I think are probably also very knowledgeable about this. And so we invite you all to ask questions and freely participate. The goal really is to secure the Internet of Things devices, and Cyber UL is one of the approaches to that, but we're also open to talk about some of the other approaches. So with that, we can get started. As I said, my name is Anita D'Amico. I'm from Code DX, and for many years I've been working in cybersecurity R&D, developing innovative technologies to bring to the cybersecurity community. One of the things that struck me about the Cyber Assurance Program, and specifically the Cyber Underwriters Laboratory, when I first read about it, was really kind of a fear that it might turn into the NIAP Common Criteria Certification Program, which I thought was really expensive and stifled innovation. And so I've been watching this very carefully to see whether or not this has the markings of what might be the NIAP Common Criteria Certification problems. So I'm going to turn this over to Kevin, who will introduce himself and tell you about why he's interested in participating in this panel. And then we'll go over to Josh. And then we're going to ask each other some questions about this, and then we invite questions from the audience. Kevin?
Thank you, Anita. Thanks, everyone, for attending. My name is Kevin Green. I work for the Department of Homeland Security, Science and Technology Directorate, Cybersecurity Division. I run a software assurance R&D program. So primarily my job is to work with academia, industry, and government to figure out how do we move the needle forward in terms of software analysis tools. How can we make tools better in terms of creating better techniques, better methods, better capabilities, so we have a higher level of assurance when we use the tools. Obviously, we want developers to use the tools early in the software development process. However, we found out that if the tools perform poorly, developers won't use the tools. So part of my job is to figure out a way, how do we bring more innovation and novelty to how we do software analysis. More and more government is using software powers, our critical infrastructure. It powers our daily lives. So we all become impacted by poorly developed software. So now I want to start by saying that overall, I think having a process in place for certified software is a really, really good idea. So I want to first start by saying that I think it's a really, really good idea. But as Anita alluded to, when I first started reading about it, I kind of took a pause because there were some questions I had, and having been on the R&D side, understanding how tools perform, because tools are a part of the process in terms of automating how we go about certifying software, analyzing software, so we have the necessary evidence to determine whether or not we can trust software, right? So understanding that there's really a lot of gaps in our state-of-the-art software, it made me, state-of-the-art software analysis tools like static analysis, dynamic analysis, binary analysis. So it really made me, it caught me off guard when I saw it, because I realized that, we have a long way to go in terms of closing that gap. So fundamentally, I think it's a really, really good idea, great idea. I'm just not sold on the fact that we have the necessary technology, the innovation around software analysis tools to get us to the point where we have enough evidence to really certify software. So that's kind of my position in terms of the value I bring to this panel is really trying to figure out how do we encourage, I should say, more innovation in that particular area so that we can have a way to certify software. We're asked to develop, people are being asked to develop software at a very fast pace. Therefore, we need to achieve security at speed. We need to achieve a lot of things at speed. And one of the ways of doing that is trying to make the tools better, make the tools perform better. So with that, I want to turn it over to Josh, give his opening statement.
Thank you, guys. Joshua Corman, I'm one of the founders of I Am the Cavalry. I'm also at a policy think tank up the street now called the Atlantic Council, running the Cyber Statecraft Initiative to try to take some of these public safety, human life concerns into the public policy and regulatory spheres. I am deeply concerned about our dependence on connected software and technology. I have been since most of you guys in this community know what the Rugged Software Manifesto was. And that was an early instinct before we were worried about the Internet of Things, whatever that means. Just to say that our dependence is increasingly on this stuff that was unreliable, right? We depend on steel and concrete. Steel and concrete's reliable. This building didn't collapse upon anybody in the last several years since it was built. But software is kind of becoming as dependent upon and it isn't up for the job. Well, a logical extension of that is now that we started putting that same vulnerable software into cars and medical devices and industrial control systems and public transportation, if we can't defend the simple amount of code in a website, we definitely can't secure the stuff that could affect life and limb. And with that intensity, I do think we have to look at minimum building codes for building code. What's Carl's last name? Who's the guy that quoted that?
Starts with L.
It starts with L. Carl L. pointed out that we don't have building codes for building code. Now raise your hand in the room, just so we clear the air and we don't get anybody frothing at the mouth. Who thinks we can ever build unhackable software? Okay, so we have a consensus, nobody. So I don't think the goal should be to come up with a seal that says this thing is hacker proof. And we're gonna get into some of the things we like and don't like about UL, but a concern, just to seed the consciousness right now, is that a UL seal on a lamp or a toaster means this will not catch on fire and burn your house down, like definitively. If we have the same organization with a similar name and a similar expectation set for something we know we can't secure, but what I do think we have to take a strong look at is we should choose something that enables the market to tell better products from worse products, safer products from less safe products, that can connect supply and demand, that can allow people to make a choice at purchase time and also manage their risk throughout the life cycle of the time they depend upon that. And while we are going to talk about what we like and don't like about UL, I decided to join this panel because I also want to talk about other parallel initiatives that may be superior at solving some of these problems. Many of you guys know who Mudge and his wife Sarah are. They have the CITL. Many of you guys know what I Am the Cavalry is. We have a framework for responding to failure, their 5-star cyber safety framework. Some of you know about the Royce bill, which is based on a rubric I worked on that basically calls for a software bill of materials and the ability to be patched. So the idea of a food label. So not perfect software, but just be transparent about the ingredients that you're using. And I think this group can't say no to everything, because if we don't make transparent, reliable, more trustworthy Internet of Things, it will affect your personal lives. It could affect public safety. And on something like cars and medical devices, it could have a material impact on our economy. So to that end, I hope we get into what we like and don't like about UL, but I hope we don't stay stuck there, because there are advantages and disadvantages in what Mudge and some other people are also doing.
So you brought up a good point. So I want to ask you and Anita, Anita, you can go first. What are some of the possible risks in something like a Underwriters Lab for software? What are some of the possible risks?
Okay, so before I start about the risks, let me talk about what the benefits are, because I think that you have to weigh the risks against the benefits. And so the intent of the Cyber Underwriters Laboratory is to help both the IoT product supplier as well as the purchaser. And from the supplier's perspective, the benefit is that you have a set of standards that you can build and test to. And that should make your product more secure. We already agreed that it's not going to make it perfect, but it will make it more secure. And from a marketing perspective, you can use, if you get the certification, you can use that as a discriminator. And so that, you can say, I'm certified and my competitor is not. From the buyer's perspective, from the purchaser's perspective, you have some sense that the product that you are buying has been tested. And so you have a sense of security and safety. Now, those things come at a cost, or they have an associated risk. And for the vendor, one of the risks is that you go through this cyber UL testing and you get let's say, a certification. And one of the things is the cost. And we don't know how much this is going to cost, but this can actually be a significant price tag. I'm still wounded from the NIAP Common Criteria certification, and so which had a $250,000 entry fee before you could just get your first level of certification. And my fear is that this may happen with the cyber UL. And so the product vendors who have the certifying, so for those who are innovative, who are just starting up, I think that the downside could be that this could have a chilling effect on getting new products to market. The downside for the purchasers is exactly that sense of security, because it can be a false sense of security. And if you buy something that is a fairly durable product, like a refrigerator, well, that software is not going to be patched very often or changed very often. But if you are buying an automobile, and the software is changed fairly often, you may say, well, I'm certified, my product is certified, I'm safe. And it really isn't, because the software has been changed a number of times.
Josh, you have anything to add in terms of some risks that you see with the UL for certifying software?
Well, I feel like starting with some benefits first, like you did. One thing that we're very technically focused here, and we like to look for what's wrong with things, but one thing that's undeniable is Underwriters Labs as an institution has been around for over 100 years and has an incredibly tight relationship with the insurance industry. And rebuilding that kind of adoption, traction relationship with every insurer would be incredibly difficult, especially for our tribe that focuses on bits and bytes and what broke and how. So that is a route to market, an ecosystem that is a tremendous asset and advantage for UL to do this. So I was hoping UL would do something material and do something well. I'm actually happy they're doing something at all, because for three times they were asked to do something, they said, hell no. So we know electrical systems, we know physics, we know deterministic science. Right. Cyber is not deterministic, sentient adaptive adversaries. So finally they said yes, and they're trying. They have that advantage, right? The other thing that's good is when you talk to them at the hospitals, I'm doing that a lot lately, people like the Mayo Clinic, they want to know that if there's 6 products to buy and 3 of them have gone through a common assurance level, doesn't say it's perfect, but they know, okay, I can shortlist down to these 3 because I know it's going to at least be patchable. I know it's at least done this, it's at least done that. And there's some sort of accountability to this vendor to do so. And when that's possible, that's a good thing. And it allows the Mayo Clinic to make smarter choices, smarter risk decisions, and make better use of their money. And in a free market, that'll drive purchasing towards those if the market adopts it. So that's also undeniable. And there's some things in the UL program I like a lot. There's some parts of it I don't. I'm going to hold off on those for a minute. But those advantages could allow someone who isn't as close to cybersecurity as we are to still make an informed decision. Right? You don't have to know everything about nutrition to know junk food from non-junk food, right? You don't have to know everything about physics to know a 5-star rated crash car, a car that 5-star crash rated car is going to be relatively safer than a 2-star crash rated car. So they create market signals that allow the people to connect with safer products when they need to. So those are the advantages I like. Some of the disadvantages, I'm very concerned as you are. I think the term we tend to use when we talk about software liability is it could create artificial barriers to entry for smaller players, and a ton of innovation comes from really small players. So to me, maybe it's not about doing UL seal for everything. Maybe it's for safety critical, industrial controls, medical equipment. Maybe it's a certain level of risk or higher, so that those players tend to be bigger or better resourced. But even that doesn't pass the sniff test in medical. A lot of the innovators have 11 or fewer employees. So I am concerned about artificial barriers to entry. I'm concerned about security through compliance checkbox, right? I railed against PCI for years because people could pass the audit, but they couldn't handle Metasploit. And there is a very real concern that we're going to replace risk management and good security with passing somebody's third-party tests, and you can study for the test. So that is also a real security concern, like your false sense of security. And I'm also worried about it keeping pace. I know that Joe's going to end up being our fourth panelist by accident because he's really close to the process, but it's an annual check on something where software risk profile changes constantly.
Right.
So they do have some things in there about ongoing patching and expectations and things like that in case a new Heartbleed comes out tomorrow after you passed it. But I am worried about what's realistic and tenable and scalable to do ongoing continuous validation of the security level of something. And that's why I tend towards more certifying capacities and programs than I do towards saying this software is secure.
I'd like to speak to that because one of the things about the Cyber UL is that it actually has 3 levels. So there's the standard is the 2009-1, which is for the product, -2 is for the industry product, and -3 is that they will do an assessment of your processes. And I haven't seen how this is going to play out yet, and I don't know how it's going to play out yet, but one of the ways that we can address the what if you have problems that come in after the certification is that if your organization has been positively assessed in that third 2009-3 set of standards, then you should have processes in place that will build the security in as you go through it. But there's no guarantee that people will do that self-assessment and follow those processes. But there is something in the standards for that.
I just realized seeing some blank faces. Do people know what the criteria are for the CAP seal? Real fast, there's 3 things I love. They're objectively true and they resemble something I've been doing for 6 years. And there's 4 things that are a little squishier and more subjective. The first 3 objectively true ones are, do you publish a software bill of materials of the third-party and open source components used in its construction? So do you have a list of ingredients so that at purchase time, people can see if you're using a known vulnerable thing? And if there's a Heartbleed tomorrow, you can do an impact assessment to say, am I affected and where am I affected? If you know how Hollywood Presbyterian Hospital and all the other thousands of hospitals got hit by ransomware, it was a known vulnerability with a CVE in JBoss in one particular manufacturer's devices. And all the hospitals didn't know that. So they heard on the news people were getting hit, but they got punched in the face anyhow because they couldn't tell if they were affected. So that one I like. Number 2, you have to have no known vulnerabilities in that bill of materials, no known CVEs without a mitigation strategy. It's pretty good, right? It's not saying you have to be resilient against 0 days. It's saying, why are you using a 7-year-old version of Bouncy Castle that has had a fix for 7 years? Get rid of that. And number 3 is you must be patchable, and you must define your patching process. That way, if there is new vulnerabilities, you can get patched. So a bunch of these devices that attack Brian Krebs were unpatchable devices. So even if you wanted to patch them, you can't. And that's not the only case where they're unpatchable. Half of the Heartbleed affected systems when Rob Graham scanned the internet repeatedly were not patchable. Those 3 I love. Now beyond those, the 4 subjective ones, static analysis with one vendor tool, dynamic analysis with a same vendor but a different method, fuzzing, which is going to be dependent on how good the fuzzer is for that type of thing. And number 4 is pen test. By whom? You know, is it a Nessus scan or is it, you know, Chris Nickerson? So those last ones are a little more subjective to me, but the idea that when Mayo Clinic goes to buy something, they know it's got these 3 things that are evergreen and true, and it's got these 4 things that it's gone through, and that they're assuming it's going to be a more secure device.
Right. So I think to kind of amplify to a certain extent, I think the last 4 pieces that you talked about, they are definitely very subjective. I wrote about this in an article the other day on Dark Reading, talking about the lack of innovation in science around making something like the UL certification come to life, right? I think it's a great idea, but part of it is also I'm gonna give a couple of numbers out. And this is something that Gary McGraw from CISU quoted. And I believe that about 50% of CVEs are related to architecture or security flaws, right? 90% of security breaches, and this was a study done by Carney Mulligan, 90%, I believe, over 90%, I think, of security breaches can be traced back to poorly designed systems. So while we're focused on testing, I think we cannot dismiss the fact there's some upfront work that we need to do on the front end. So when we start making decisions about the architecture, that we're making good decisions about architecture, right? So that when devices are out on the internet, we know that they can be patched, right? That was a poorly decision that was made about the architecture where you can't patch it, where it's incapable to patch a device. So I think there's some things on the front end that needs to happen, and we need to have a way to validate that and make sure it's process driven and is part of everyone's development process, right? Where there's good architecture decisions made up front so that guides the efficiency of static analysis, fuzz testing, and all these other testing things that we do as part of what I call continuous assurance. So that's kind of one of the things I think is a risk, is that, I don't want to focus so much on the testing aspect of it, but we need to be able to focus and have a way to validate that we're building something with good intentions, with good architecture decisions up front, so that, the architecture won't erode over a period of time, as we've seen recently with the Johnson & Johnson revealing the 4 vulnerabilities associated with the insulin pumps.
Well, and one great point that we tend to ignore in this is, while we want to see more testing, because there's almost no testing being done on these safety critical things, that's a trailing indicator. We're enumerating mistakes. Right. Mm-hmm. It's not a leading indicator. Here's good design patterns and good architectural choices. And one of the things I mentioned at the opening was the Cavalry published a 5-star cyber safety framework for cars. We didn't talk about using this tool or that tool. It basically says all systems fail. Here's 5 postures every safety critical system needs for failure. Tell your customers how you avoid failure. That's like publishing an SDL. Tell your customers to take help avoiding failure without suing the researchers. So that's, do you have a coordinated vulnerability disclosure program? Number 3, how do you capture, study, and learn from failure? Do you even have the ability to capture actionable evidence of hacking? Most of these devices don't. So it's, to use a Dan Gearism, no silent failures.
No silent failures.
Number 4, how do you have a prompt and agile response to failure, which is a requirement to have updates and update capability. And number 5 is, how do you contain and isolate failure? So you separate critical systems from non-critical systems and avoid these big cascading things. So that was not about, do you have bugs or can a static or dynamic analysis find stuff? It's that when something's found, what are you doing to avoid it? Take help avoiding it, notice it and learn from it, respond to it, and contain and isolate it. Now, if someone has a program and they're starting a maturity model on top of that program, like, well, we're doing really well in the patching, but not so well in secure design. Let's go learn from others about how to improve our secure design and architecture. So I'm not saying one's better than the other, but we should look at something like a testing regime as a trailing indicator, not, a keys to the kingdom for success.
When I looked at the 5-star program that I Am the Cavalry came out with, and the first star is safety by design, right? To me, that sort of maps onto the cyber UL, right? Because it deals with all kinds of testing. It's design and the testing within that design. The other 4 stars don't seem to be captured by the...
Well, they do require updates, so star number 4 is there.
Okay, star number 4. But the other 3 stars, really aren't represented in the cyber assurance protection program.
Sure.
Getting back to the testing for a minute, that's one of the things that concerns me, is that Underwriters Laboratory has a really good reputation, and people believe that if it's certified, it's a plug in the wall and it's never going to fail. Mm-hmm. And that is a plus and a minus. It has great market recognition, but at the same time, there is an expectation that anything that has the UL seal is not going to fail. And we know that the tests, the static and binary analysis tests that they do on software don't find all the weaknesses. That is a fact. And so we're going to put it through a set of tests that we know are going to be incomplete in their coverage of the weaknesses. And yet it's going to get a certification. We also know that in order to find the most weaknesses in software, you have to run a whole bunch of different tools. And yet, right now, I think the Cyber UL is only using one static analysis tool. And they really need to use more than one. There's nothing wrong with the one that they're using, nothing wrong with Coverity, but it and everything else is incomplete in its coverage of weaknesses. So we have to run more than one.
So it also comes with context, right? So when you're testing, what is the context in which you're testing? I mean, I could run static analysis, could run dynamic analysis, but if I don't really understand context, touch points in terms of where sensitive data may reside, it kind of defeats the whole purpose. So all I'm saying is, I think there should be context so that you have guided testing, so that you can find those things that impacts you the most. I think that's something I would like to see amplified in the UL certification. Another thing is, I work for Homeland Security. I have not or been asked to comment on the UL standards. So I've heard a lot of people talk about transparency as it relates to the standards. So, should we accept something without having a general body provide comments and help shape how we are going to go about certifying software? I think we should. There are a lot of great folks in academia who can potentially chime in. There are a lot of folks in industry who can chime in. There's a lot of folks who are doing policy stuff that can chime in. So right now, I'm not sure how much review the standard has gotten in terms of having open for comments and feedback. But I think there is an issue with transparency. I've heard a lot of people complain about it on LinkedIn. I've heard Anita share her concerns about transparency. So that's only one of my also concerns is I'm not sure if there's enough transparency as it relates to the process.
And this is a tiny little point just before we leave this topic. I've heard a lot of people say, oh, wow, they're doing static and dynamic. It must be twice as secure. But they all think that just because you did the test means you fixed all the bugs found,
right,
and triage which ones are false positives and whatnot. Has anybody ever fixed all of their findings from a static and dynamic analysis tool? Anybody? All right, again, we have a consensus.
Right.
So just because the test was done doesn't mean you've actually properly acted upon the findings.
Right.
So I'd like to bring up another topic, and that is we've been talking about a commercial software that would go through this kind of testing. But how will the UL impact open source community? Since many of the software systems
Josh,
use
why
open
you
source.
Never mind.
So I'm going to contain this to a very small amount since I spent too much time on this one.
Go ahead.
No, this one has to be contained. There's both, most commercial software, whether everyone's figured this out or not, you look at a modern piece of commercial software, 90% of that piece of software is open source. So the idea that open source is more or less secure than closed source, it's a distinction without a difference when it comes to security. There are also tools that aren't sold. They're open source tools or open source packages. And I don't know how they're ever going to pay for this sort of validation. So on that aspect, that's an interesting question for if you ever wanted to get a UL certified free tool, who pays for that? That's a great question. I think the positive effect, if you look at the way UL did it, remember I like those first three criteria a lot of a known bill of materials, known vulnerabilities. I think what that's going to do is it's going to drive people to start scrutinizing which open source projects they use, because projects that have really bad hygiene are going to be really hard to get through the UL program because they're going to have too many known vulnerabilities in them. And ones that don't fix their bugs very quickly, it's going to be really hard to patch on time. So I think a good part of the transparency they're requiring in the bill of materials and the known vulnerabilities and the patching is that people are going to leave the logging frameworks that are poorly maintained and they're going to go towards the logging frameworks that are better maintained. They're not going to use like the really abandoned derelict of projects. They're going to use the better projects. They may not use a huge open SSL that's impossible to clean up. They might use like Libre SSL or Boring SSL or S2N, which are these smaller alternatives.
Right.
So I think it could have a very positive effect on culling the herd
But that's a good idea, because if we can somehow change the culture or the mentality when folks go look for open source components in third-party libraries, if we can help influence their decision-making.
That's right.
In selecting components with a reasonable amount of good hygiene, I think, and also if we can figure out which components has, over a period of time in terms of attack proneness and defect proneness, if we can somehow figure out how to select components based off of that. So over a period of time, we're patching less, right? So I think that would be good. One of the biggest questions I've always tried to figure out, and even through my program at DHS, trying to come up with creative ways to help the government solve software vulnerability problems is okay, we find it, now what? We find bugs in open source software, vulnerabilities in open source software. Who's going to fix it? What if it's a project you're using and there's not a lot of, we've seen this with OpenSSL. At the time, I think there was one full-time developer and 2 part-time developers initially around the time when the weakness that exposed the Heartbleed vulnerability was made available. Since then, they put additional resources to OpenSSL. So what about some of the neglected projects you talked about? How can we shorten and reduce the window of exposure around a lot of critical components that not only the government use a lot of, but a lot of industry use? How can we create, I don't want to just throw this out here, a crowdsourcing or incentive-led approach to fix these open source projects that really need help? A lot of these open source projects needs help in terms of, creating fixes for a lot of very vulnerable software.
Do you have an answer to your own question?
No, I wanted to hear from you. But I wonder actually about, in addition to how does CyberUL handle the open source? I mean, there's liabilities associated with the open source, and who's liable.
Well, no one's liable for any software. But was that a trap question?
Well, I wanted to actually turn this over to talk a little bit about software liabilities.
So before we answer that, how can you assign liability to bad software when at the time, let's say for instance, we use a set of tools, and at the time we use the tools were at a certain level in terms of its ability to find a certain range of potential weaknesses. Let's say 7 months from now, hopefully tool vendors will improve their tool. So between the time the initial set of innovation for the tool was out to the time that the improvement was made, if things are found that cause harm or there are safety issues, like how do you assign vulnerability? How do you assign liability to something when we don't have ground truth in terms of what these tools are actually finding? I'm trying to figure out how do you assign? I think software liability is a good thing, assigning liability to folks who neglect good hygiene, good security practices. But how do you prove that when our current capabilities are not up to par?
Well, yeah. So can I retreat the question a little bit? Because sometimes
Sure.
when we use the word software liability, I might need an ambulance called or some other people's heads might explode. So why don't we retreat it back a little bit and just say, what is due care?
Due care.
What is negligence? What's reasonable expectation of a software vendor, regardless of liability, which can sometimes come with that? Across FTC, parts of DHS, parts of the financial services, ISAC, there was a congressional bill I helped with called the Cyber Supply Chain Management and Transparency Act, 2014. Everybody seems to be harmonizing around the idea that you're not responsible for 0 days from Russians and China. What is potentially reasonable is, are you using known vulnerable components with known CVEs at the time you ship the product? And even that wasn't really the standard. The standard was, are you at least telling your customers so they can make an informed risk decision? So if you got to use a known vulnerable version of Struts because you need that API version, just disclose it.
Right.
So some of the trial lawyers, some of the insurers, there seems to be a harmonization around those two words, known vulnerabilities. Now, even if you get rid of the known vulnerabilities, you're not going to make hack-proof stuff.
Right.
But given the unbelievable attack density towards known vulnerabilities that have been around for 10 or more years, it's much better than 80-20 rule. Like if we can get our arms wrapped around known vulnerabilities, that would be huge. Doesn't make things perfect, but that's a huge step. That's a reasonable step. And maybe there's liabilities associated with it at some point, maybe. But the second thing is, when you try to think about which adversaries are most likely to target the safety critical stuff that we care the most about, the things that might lead to a loss of life and limb, we have this little XY axis, right? There's capability and there's intent. Now, someone like Russia, China, Israel, us, we are APTs, right?
All right.
I hate that term, right? We are really high capability, but we use restraint because we have economic sanctions, mutually assured destructions, treaties, norms. It still happens,
Right.
but you're never going to be able to stop those guys. But there's another group of actors that are high intent, low capability, and they're not very talented, but they're talented enough to use Jodan and Metasploit and Kali Linux and Poison Ivy. And if we can raise the hygiene level above their current capabilities, then the threat actors we care most about for these things go away. So known vulnerabilities happen to be one of the more reasonable things, one of the easier ones to address, and a higher impact on the people most likely to take advantage of those. And if somebody died in Hollywood Presbyterian Hospital, or if the next piece of ransomware kills people, it's not gonna be a 0 day. It's gonna be a known vulnerability.
Right. So I want to shift real quick to another area around UL, and then after we address that, we'll open up for comments. So if not UL, then what? What would be some realistic approaches? You mentioned Mudge, what Mudge is doing. I like the whole
Mudge and Sarah.
Mudge and Sarah. Sorry, Sarah. I like the whole consumer report thing. I mean, at least it gives the buyer, evidence to make an informed decision about what they want to buy, what risk they should or willing to incur. I like software labels, I think that's important because it provides visibility into, how software is actually assembled and built. So I think that's good. So if not UL, what are some other things that we can do to address this issue?
Well, I mean, the one that came to mind, the first thing was the Mudge and Sarah nutritional labeling, because you at least want to see what it's made of. And
They don't say that. They don't say the label, the ingredients list. They give you a FICO score essentially. Yeah.
And then of course the 5-star system is very interesting, and I think it covers a lot of things that CyberUL doesn't.
Yeah, I mean, I had some good conversations with Sarah Zatko, and she was also one of the testimonies on food labeling and what to do about this for the Presidential Commission. And she had, I think we're all approaching it from a different perspective. If you don't know what the CITL is, it's Cyber Independent Test Lab. And they're looking at binaries, and they're using a consistent measurement methodology across binaries. So you take a bunch of browsers and you go head to head. Take a bunch of antivirus products, you go head to head. It's not going to do a medical device, which is composed of thousands of binaries.
Right.
It's not going to tell you the risk score of an enterprise, which has thousands of devices with thousands of binaries on each. But if you want to know which browser is doing a better job on things like compiler flags and all sorts of other stuff, it's a pretty good, consistent measurement tool. And that's why I think it's more like a FICO score.
Right.
She had a really good point. She said, look, having a measurement system or food label doesn't mean you can't sell junk food anymore. It just makes it really, really clear that you're eating junk food.
Right.
And she also said you might not know what monosodium glutamate is, but you can consult with a doctor or a dietitian to help you make the right choices for you in your risk context. So that's an available thing. But one of the things we argued over a little bit is said, what's more important, that it has the right compiler flags or that they can patch a vulnerability quickly, or that they have a coordinated vulnerability disclosure program so that someone who finds a flaw can tell them and they can patch it more quickly. So I don't think it's an and, I don't think it's an or. I think there are going to be advantages to different things. And the consumer reports of which browser is more secure, I would love to have that. And I'd like to see that program scale. Something like a device, I think you got to look at something like a UL-ish thing or a 5-star. And then the last one I think kind of fits for everybody, which is that little trio of the Royce bill, the bill of materials, no known vulnerabilities without a mitigation and patchable. You could apply that for everything from a Siemens industrial control system like Stuxnet attack, all the way down to like a home IoT device in your kitchen, right? I mean, that could be useful.
I think the bill of materials and the Royce, I wish the Royce bill was actually passed.
Oracle and some of the big software vendors didn't like it very much.
Really, but I think that's really something that the industry needs, because it really provides visibility into what you're buying. Tom?
So I'm interested in your opinions that at 3 o'clock we have Corey Doctorow speaking about DRM in particular. Well, I'm interested in DRM and IoT because I think these things are interesting together. What's your view on DRM and IoT working together to help organizations control the product they actually produce and protect people and the safety and the life of others?
Was that also a friendly reminder that we're only supposed to go to 3?
think you're on the 315.
315.
Yeah, I kind of want to go see Corey.
Yeah,
I don't have a well-formed thought on DRM for IoT, other than DRM usually causes more problems than it fixes. But
You had a question right there?
I was just gonna,
Anybody else have anything?
I was gonna let you know that there is a company that is a very large company that has already done what you're suggesting on open source languages. And what they've done is they've migrated away from languages that don't patch within 3 weeks. And so their K-lock has dropped through the floor because of that. But I just have a general observation that, you know, it sounds like a lot of what I'm hearing is, you know, we have to have it perfect. Good enough isn't good enough. And right now, we're getting hacked to our knees, okay? And if we make it through the election without a hack, I'll be shocked. So, you know, I would suggest that the public may be getting impatient with, oh, we can't, we can do 17 tests, but it's still not enough. You guys have to figure out something that is enough.
Well, I mean, one thing that wasn't discussed here that I think probably needs to be addressed is the educational piece. You know, how do we teach, you know, our next generation of software developers how to develop good systems, how to design good systems? I think that's a piece that we cannot forget, but you're right. I think having something perfect to me is not an option, but just to do something, just to be doing something is not an option as well. To me, it has to be meaningful. It has to provide value. And that's just my only concern. I just like to see something that has value. And I'm just a little bit still on the fence. There's so many things about UL certification that have not been presented to the public. I haven't seen anything since April from UL standards around software security. So there's a lot of things for me. I'm still learning what's going on. So that's just my only concern.
You know, before we change too much, I kind of want to do a show of hands for which one's the least ugly or least unattractive of these options. One of my beliefs is that we don't have the right answer. So if you guys know about DevOps and Lean and Agile, right? One of the philosophies is parallel experimentation, right? Try lots of things, see what works. Right. Instead of crapping all over something that might be wrong, you kind of have to stumble and fumble towards the right answers. So I'm fine with us having a lot of things to try right now, and we can learn from those experiments. But real quick, if you had to choose, you can raise your hand twice. If you had to choose between the Underwriters Laboratories cyber assurance program as described versus the CITL from Mudge and Sarah for the analysis of a binary, I know it's apples and oranges, versus something like the 5-star for making sure you're ready for failure and can respond to failure, versus something like a software bill of materials so that you can at least make informed risk decisions and respond quickly when there's an attack. You can only vote twice. Who's a big fan of the cyber UL thing? Okay. Who's a big fan of the CITL psycho test? Okay. 5-star readiness for failure. Okay. We're getting a very scientific poll here. And what about software bill of materials for informed risk decisions?
Raise your hand twice.
Well, Joe's right. You do get the bill of materials in the UL, but you get less baggage. So I don't think we have it figured out, and I'm hoping we can look for what's right with these things, and maybe even.
Tell us what the results were.
Oh, if you guys weren't looking backwards, it seemed like people like the UL and the bill of materials best. Yeah. Is that what you guys experienced as well?
Yeah, UL bill of materials probably mostly, but if you incorporate bill of materials associated with UL, then I guess.
Yeah.
I've been quiet the whole time.
All right, Joe has something to say.
So, first of all, I mean.
You don't have a mic unless you come up.
Take this one.
And it was good that you actually brought out the benefits of saying, because UL has a strong reputation with the insurance industry. Insurance is going to drive this quite a bit. Understanding that you had a choice of choosing something that was independently tested with a certification, or you chose something that wasn't, something went wrong, which one did you choose? What do you think your insurance position is going to be? And that's a huge driver what's going to make that happen. Now, you started bringing up what you were concerned about what it might be, FUD, fear, uncertainty, and doubt. And that's kind of unfair, especially Kevin, you saying, because the very first meeting UL had was with all the federal agencies. The fact that you didn't come to the meeting, don't say DHS was pushing this.
Well, what I'm saying, I wasn't, no, let me take that back.
Yeah.
I was not aware of it.
Yeah. So we actually.
But Joe, don't, you can't sit up and just say that. Don't come at me like that.
Yeah.
But what I'm saying is, there's a lot of, just because you give one pass or something, doesn't mean, doesn't mean that there's transparency, there's openness to receive comments. A one pass or something doesn't mean that.
Yeah, but it wasn't one pass. We actually helped design what the criteria was that they were going to be looking for. And the other federal agencies weighed in on that. And,
Like who?
including NSA and FDA, and all the DoD partners, and DHS was a big, I mean, look, for years we've been saying we need a UL-like rating for software. The fact that UL stepped up to the game finally was amazing.
But the point is this also, it's just not a government initiative.
No, it's not. And that's exactly right.
You know, you got
And that's
Bart
what the White House.
Miller, was Gary McGraw part of it? Was Chris Weisselpole part of it? These are all thought leaders in AppSec. There's a lot of folks who have not had opportunity to chime in on the standards, and that's all I'm saying.
Yep.
It's not just a government initiative.
It's
it
just
should
like
be an industry
most
initiative.
standards process, people can join standards.
Well, there's something called invitation. You send an invitation to people to get the thought leaders to come to the table. I don't think that was done. If you have that as it was done, then I apologize. But I don't think that was done.
They have, in fact, the very first standards technology panel for it is tomorrow. We're having our kickoff meeting. And that's to go through their normal process. UL has been, I mean, they're looking at how global this is.
I know all the Synopsys folks are invited, but I don't think everyone else in the industry is invited.
Well, Josh is invited. I don't know if he's going to attend. So
and Stan from HP was here. I don't think Stan was invited.
But the other part of it is you started bringing in a lot of other things. You started, what about open source? What about, it's like, wait a minute, this has got to be able to scale. They're starting with industrial control systems and medical devices.
That's a good place to start.
And so that was important to be able to look at that. And so they will scale over time, but it's a huge undertaking. If anyone understands what this takes. So I'm not pleased at the rate it's going. I'd like to see it
So
pass.
if it's a huge undertaking,
Yeah.
let's go slow.
Some people think they're going too slow now.
And let's go slow and let's get the experts at the table so that this can be something that is widely accepted by everybody, not just a small.
But instead of litigating it right now, AP's feedback that as a representative you could bring is that one way to get more traction is to get the buy-in of this digitality.
Yep.
I think
Question in the back?
Yeah, sorry, I have a question, especially with talking about sort of scaling and forms of liability, especially with the fact that insurance will be helping push some of these things. When we're talking about things like medical devices and security, things make sense with trying to stop things like, buffer overflows or ransomware or exploits of that sort. But what about the questions of, related topics like safety or privacy and some concerns that can happen there? So let's say there is a certified medical device that's purchased. There is something that's wrong with the software, the algorithm. That wasn't checked necessarily in the certification process. And something goes wrong because of that. And someone dies. I guess, where in that sense would the certification apply to things like safety? And again, same thing he said, like sort of privacy and things like that.
And to explain, they will not be talking about and looking at the functionality. They're looking at the security of it. Like Josh indicated, for known vulnerabilities, we're looking at exploitable weaknesses. So yes, that is an issue, but it's not part of the coverage. Just like the concern, well, it could become a common criteria. It won't. UL has 2 common criteria labs, but they understand that you're not going to have a medical device go through a common criteria evaluation. It's making it something that is scalable to be able to do it.
So part of your answer in the time we have, and I'd be happy to talk more, is the Food and Drug Administration is the regulator of record here. So they're going to do things irrespective of what UL does. And some of those things focus on the confidentiality of personal health care information, on safety hazard conditions, and they have modeled most of their pre-market guidance and post-market guidance off of the 5-star. We actually, in medical, the Cavalry wrote a separate one called the Hippocratic Oath for Connected Medical Devices. It's essentially the same 5 things. And they're doing some things and they're improving over time. And just like somebody back there said about these things don't have to be perfect, FDA knows they're not perfect, but they're taking steps, and they do, unlike the UL thing, they have a very obvious, open, public commentary period for 90 days. and they take that feedback. So I think we should be encouraging the good parts of all of these things, participating, giving a constructive criticism. And I think some combination of FDA, the UL type thing, and even FTC, Federal Trade Commission, which has some consumer protection law enforcement capabilities, amongst the three of them, you might get some good stuff for the medical devices. A little bit different for cars, right? It's going to be NHTSA or NHTSA, right? So don't look at the UL as instead of government. There's still a role for government and regulators. There's still a role for law enforcement. And there's still a role for UL, which is still a private sector thing. It's almost like a self-regulatory. There's ISO standards. We have an ISO editor in the room. I mean, there are other standards bodies as well. And the ones that work are the ones that have the most buy-in and get the most traction. And none of them are going to make you immune to attack, right?
We have time for one more question, and then I think we have to wrap it up. Jason?
I mean, I think it's important to, first of all, based on our last comment, is it's important to understand that software security is part of the overall quality of the software. So you don't always want to separate security from functionality, because security is usually just an abuse of your functionality, using it in a way you didn't intend. So in that vein, I really like the idea of what's the alternative word you use, Josh, as opposed to liability?
Due diligence.
Negligence, due care. Yeah.
Combine that with the bill of materials is really, for me, where you get the game, right? Because for the first time in a long time, about a year ago, I worked with a developer who didn't just grab a new library or package or framework to implement a certain feature. He realized he only needed a small subset. He didn't need the 50 things that thing did. He needed 2 of them.
All right.
So he built his own. Now, I'm not saying his code was more secure or better,
All right.
but he didn't inherit the entire surface.
Less attack surface. Yeah.
Less attack surface in this case, and there wasn't really a lot of attack surface, but the principle being, he didn't inherit all the problems of that when he did that. Now, if he needed 45 of those features, fine, then maybe he could. We've kind of lost sight. I remember back around my early CGI days, we used to evaluate open source software if we wanted to use it. We used to be more rigorous. Now it's
Grab.
Now it's Ryan Burley, I think.
Yeah.
You refer to it as the bacon principle. Everything's
Yeah.
better with bacon. So you just grab it and throw it on.
Right.
Right. So I think that combination of the bill of materials and I'll call it accountability.
Yeah.
Put together are really, if we're going to take small steps, I would make that the first step.
But I also think that's going back to one of my previous comments about making good architecture decisions up front, so that you are selecting known good components that, as Josh would say, reduce the attack surface or kind of.
And the implication is that the accountability should drive that.
Right.
Should drive
Yeah.
you to do that.
Right.
Just a real quick stat. In fact, they might even have it over at the Sonotype booth. One of the first things I did there is I called Dan Gear and I said, can you and I do a quantitative analysis of the mean time to respond for open source projects? So not like, did you introduce a flaw into your code, but we asked 2 questions. We said, when an open source project in Java, because I had all the Java data. So when an open source project has a dependency with a known vulnerability in it, which percentage of the time do they ever fix it? And how quickly do they fix it when they fix it? 47% across all of Java, only 47% of CVEs ever get fixed. And the mean time to remediate was like 391 days. So when I looked at that at the macro level, I was like, wow, this is terrible. But then if you look project by project, some logging frameworks fixed almost all their bugs within about 3 months, and some of them never fixed. So had you never asked, your component selection would have been just whatever you're used to using.
Right.
Or whatever's popular. And then when you looked at, okay, which one's got good hygiene, it didn't correlate very strongly with some of the other things.
Right.
So what you really want to look for is the stuff that has the most code you need, that's best maintained, and does a good job in their hygiene. Otherwise, you're going to have a really hard time with this due care standard. So unshockingly, I agree with you.
Well, I think that's it, everyone. Thanks for coming. Appreciate your comments and feedback, and hopefully, we can move forward to embracing something to help us improve software security. So, thank you.
Thanks, Josh.
Really been a pleasure.
Is that close enough to what you would hope?
Thanks, Anita. Thanks, Anita.